Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, in this episode of ICAR training, we're going to be looking at some sample questions of the ICAR examination. We'll be looking at some of these questions based on different subjects, and we'll be looking at how to solve them effectively. So let's start off with a match type question. Match list 1 with list 2 and choose the correct answer from the options given below. So in list 1 we have Streptococcus, Thiobacillus, porins, and Beigernichia. And in list 2 we have diffusion, nitrogen fixation, denitrification, clot buster. And we have 4 sets of the matches for these two particular lists. So let's look at how to solve this question. Well, the best idea is to match up stuff that you already know and then refer to the options to find out the correct match. Now, if you look at option A, Streptococcus is a bacteria that produces streptokinase. And this streptokinase is actually known to be a clot buster. So therefore, A4 is a correct match. So that means options A and C are incorrect, because in both of these options, A is not matched to number 4. So the answers would lie between B and D. So these two options, one of these two options would be the answer. Now in both of these options, we know that the letter B is matched to number 3. That is Thiobacillus denitrification. So we know that this is also correct. Now, the only confusion here is with C and D. So, how do we look at it? We have porins and Beigernichia on one hand, and on the other hand we have diffusion and nitrogen fixation. So let's look at C, porins. What are porins? Porins are essentially proteins in the plasma membrane which form channels for passive transportation. Now, an example for passive transportation is diffusion. So therefore, porins would be correctly matched with number 1, diffusion. So C1 is actually the correct match. Now, the option having A4, B3, and C1 is only present in option B. So therefore, the other options turn out to be incorrect. So options A and C are incorrect because they had a mismatch of A, and option D is incorrect because C is being mismatched with nitrogen fixation, whereas in fact it's Beigernichia which deals with nitrogen fixation. So therefore option B, A4, B3, C1, D2 is the right option. Next question. A section of double-stranded DNA is composed of 41% adenine bases. What is the percentage of cytosine bases in this section of DNA? Well, how do we solve this question? Well, if you look at the structure of DNA, DNA is composed of nitrogenous bases, sugar, as well as a phosphate. Now, these nitrogenous bases are paired up in the following way. Adenine is paired with thymine by 2 bonds. Cytosine is, paired with guanine by 3 nitrogen bonds. So these are the 2 bonds that are present. These are the 2 base combinations that are present in the DNA. So what does that mean? It means that the number of adenine is equal to the number of guanine. Is equal to the number of thymine. Similarly, number of C is equal to number of G. So if we know the percentage of adenine bases, then we can easily calculate the percentage of any other base. Now, adenine is 41%, which means that thymine is also 41%. So if you add those two together, then you get a total amount of 82% of the bases in that section of DNA being made out of adenine and thymine. Now, the remaining percentage values, value would be 100 minus 82, which is equal to 18%. Now 18% can be divided into 9% and 9% for the remaining two bases. So there'll be 9% cytosine and 9% guanine. We need to find the percentage of cytosine bases in that particular section, so therefore the right option turns out to be option B. Option C is incorrect because that value does not exist here. Option A is incorrect. It's the value for both cytosine and guanine together, and 82% is the value for both adenine and thymine together. So 9% is the correct answer for the percentage of cytosine bases in a section of DNA having 41% adenine bases. Now let's look at a chemistry question. This one again is based on matching up list 1 with list 2. You need to find the correct answer from the options given below. We have 4 structures with benzene rings on list 1, and on list 2 we have catechol, resorcinol, hydroquinone, and orthocresol. So we use the same formula here. I believe the most popular one would be hydroquinone. Hydroquinone is actually also known as benzene 1,4-diol. That means in a benzene ring you would have 2 OH groups, and the first OH group would be at position number 1, and the other OH group would be at position number 4. So if you take 1 here, then 2, then 3, and then 4 would be here. So they would be opposite to each other. So therefore, as you can see, B is directly connected to 3. So B is matched with 3 is a right match. So therefore, the correct answers will only be between A and D. Options B and C are incorrect because they say that B is 1. They say that this particular structure is a catechol, which is wrong. Now, since we know that hydroquinone is B on list 1, we can also, deduce that A is 1. A, that is catechol, would be 1. And catechol is, in fact, 1,2-dihydroxybenzene. So therefore, that works too. Now we have resorcinol and orthocresol on our list that's remaining, and 2 structures, C and D. Now if you look at orthocresol, in a benzene ring, the ortho position is positions number 2 and 5 on the ring with respect to the initial functional group, and the para position is position number 4. The meta position is position number 3 and 5. So that the position where ortho is actually 6. So since option 4 said orthocresol, then it has to be where the secondary functional group is in the ortho position. So D is matched out with 4. So if you look at option D, it says D is matched out with 2. That's incorrect. D matched with 4 is the right option. So therefore, option A is the right option. If you look at resorcinol, resorcinol is benzene 1,3-diol, which means that it's matched up with C. So therefore, option C, compound number C being list number 2, being number 2 in the list, is actually correct. So option A is the correct match, the correct answer containing the right matches. All the other options are incorrect. Now let's look at the final question for the day. The total number of chiral carbons or centers in beta-D ribose are 3, 4, 5, and 2. Well, in order to solve this question, we would need to draw out ribose. So this is what it would look like. The structure of beta-D ribose is like this. So we have an oxygen, which is connected to 4 carbon atoms. 3 of these carbon atoms have an OH group and an H group connected to them, and then the 4th carbon would have a CH2OH group connected to it. So therefore, this is how it looks like. So let's start solving it. For that, we need to understand what is a chiral carbon. A chiral carbon is basically a carbon atom with 4 separate bonds, 4 separate atoms bonded to it. So the idea is that we have 4 separate atoms bonded to it, a carbon atom, so it's called a chiral carbon. Now, if you look at carbon number 1, it's connected to an oxygen atom, it's connected to an OH group, it's connected to an H group, and it's also connected to a CHOH. So therefore, it's a chiral carbon. If you look at 2, you can see that it's connected to an OH, CHOH, an H, an OH, and a CHOH. So as you can see, different, 4 different groups. So therefore, this is also chiral. Similarly, 3 is also chiral, and 4 is also chiral, because 4 is connected to oxygen, hydrogen, CHOH, and CH2OH. So therefore, the correct answer is option B, 4. There are 4 chiral carbons in beta-D ribose. Option A, 3, option C, 5, and option D, 2 is incorrect, because that's not the right number of chiral carbons. There are 4 chiral carbon or centers in beta-D ribose. So that concludes this episode of ICAR training. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rankmate, your partner in education. If you want to get the latest updates from our channel regarding ICAR or any other examination, then please don't forget to hit the bell icon present below the video and set it to all. So until the next webisode, take care, stay alert, bye-bye for now.